Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to go over how to get the empirical formula from the percentages of each of the elements in that formula. So let's get into this. So the first thing you want to kind of keep in mind is that the empirical formula is a mole ratio, the simplest mole ratio of the elements in that compound, right? So once you realize that we're looking at mole ratios here, then our goal here is to convert our percentages to moles of the compound. That's our goal. That's it. So what do we do? So the first thing you want to keep in mind, especially if you're given percentages, is to assume that you've got 100 grams of this substance because these are percent by mass, right? So this is the amount of of potassium in your substance. That's 56.50%, right? And so the carbon is 8.75% of whatever mass of the compound you have. So since percentages are per 100, that's what percent means, per 100, right? Think of the word century, cent 100, century 100 years. So percent means per 100, out of 100, whatever, right? So in this case, if we're having mass percents, then why not assume that we have 100 grams of our substance and then go from there? Once we assume we have 100 grams of our substance, we can convert the percentages to grams because out of 100 grams, 56.50 grams is going to be potassium. So we could start with that. So here I'm going to write it this way. So 56.50 grams out of 100 grams of our substance is going to be potassium. And then out of 100 grams of our compound, 8.75 grams will be carbon. And then again, out of 100 grams of our compound, 34.75 grams is going to be oxygen. So that's the first step. Now that we have grams, we now to get to moles. We have to get to moles because we need to get a mole ratio. So how do we get to moles? We use the molar masses of our elements to convert from grams to moles. So we look up the molar masses of each substance. So potassium is 39.10. So we're going to take the 56.50 grams of potassium, and we're going to use the molar mass. So 39.10 grams of potassium and 1 mole, because 1 mole of potassium is equal to 39.10 grams. So the grams cancel out, and then we can calculate the number of moles. So let's go ahead and do that. We get 1.445 moles of potassium. And then we do the same thing with carbon. So we're going to take our 8.75 grams of carbon over 1. We're going to multiply that by the molar mass of carbon, which is 12.011 grams. So 12.011 grams of carbon on the bottom, 1 mole of carbon on top. So grams of carbon cancel out. We calculate the moles of carbon, and we get 0.7284. So 0.7284, and that's moles of carbon. And then finally, we do the same thing with oxygen. So we get 34. So 34.75 grams of oxygen over 1. We're going to use the molar mass of oxygen. So that's going to be 15.9994 grams of oxygen, or you could just say 16.00. It's up to you. And that's going to be 1 mole of oxygen, right? And notice we're not using the molecular oxygen O2. We're just using the atomic oxygen because we are looking at the mass of the atoms, not the molecules of oxygen in our substance. So grams of the oxygen are going to cancel out. So we're left in moles. So we're going to calculate the molar mass of, or we're going to calculate the moles of oxygen. And we get 2.172. So 2.172 moles of oxygen. Okay, so that's step 2. Now that we have the moles, now we need to have a mole ratio. So what we're going to do is we're going to build a pseudo formula. So as you know, the subscripts in your formula make up the mole ratio. So for example, if you have H2O, that's the formula for water. The subscripts give you the mole ratio between oxygen and hydrogen. So we have a 2 and a 1. We don't write ones, but the ratio is 2 to 1. We got whole number ratios. That's what we want. We want whole number ratios, so that way we could write them as subscripts. So basically, these numbers here are the subscripts, but they haven't been put into whole number ratios. So let's make a formula with these numbers in it, and we'll get the whole number ratios in a moment. Right, so let me go ahead and erase here so I can give myself some room. Right, so we got our moles. Okay. So here's the moles we have, and so my pseudo formula is going to be K with 1.445 moles, with that as the subscript. And I'm going to have C as 0.7284 for its subscript. And then I got oxygen, and then its subscript is 2.172. Okay, so there's my pseudo formula. The subscripts should be whole numbers, but they're not. So how do I get these into whole numbers? Well, to get into whole numbers, I want a ratio of 1 to something, right? So in order to get the ratio of 1 to some other numbers, then I need to divide everything by the smallest number, because if I divide larger numbers by smaller numbers, I can get a number greater than or equal to 1, depending on what I'm dividing. Right? So I don't want fractions as whole numbers. I'm sorry. I don't want fractions as subscripts, because we don't have fractions as subscripts. Right? We have whole numbers as subscripts. So I need to divide by the smallest number. So 0.7284 is the smallest number. So I'm going to divide everything by 0.7284. 0.7284. And then what do I get? Let's see what I get. Okay, and so when I do, I get a number here. This is 1.98. And of course, this divided by itself is going to be 1. And then when I divide this by oxygen, I get 2.98. Now, these numbers here are really close to a whole number. This one's really close to 2, so you can round that to 2. 2.98 is really close to 3, so you might as well round that to 3. If this was something like 2.9, I wouldn't probably round it. Something probably is wrong there, but usually you get a number really close to the whole number, maybe 3.01 or something along those lines. If you get something like 1.75, you might multiply that by 4 or 2, 4. Or if you get 0.333 somewhere, that might be a third. So you might multiply by 3. But usually it's going to be a number close to a whole number. Or if you don't get a number close to a whole number, it might be like 0.5. In that case, you'd multiply by 2 to get the empirical formula. But in this case, these are really close to the whole numbers. So I'll just round those to the whole number. So I have K2 and then C. and then O3. And so there's my empirical formula. If I'm being asked to name this, it's quite obvious that I have the potassium ion, and here I have CO3, which is the carbonate ion, because the carbonate ion has a 2 minus charge and the potassium has a +1 charge, and I have two of them. So this would be potassium carbonate. So potassium carbonate would be the name of this substance. Okay, let's go to the next one. Same thing. I'm given the percentages of each of the elements, and I'm asked to find the empirical formula. So first thing, I assume that I have 100 grams of this stuff, and I convert everything to grams. So out of 100 grams, I'm going to get 35.172 grams of potassium. For sulfur, I'll have 28. Let me move this down a little bit. So I'll get 28.846 grams of sulfur, and I'll get 35.982 grams of oxygen. Now that I have the grams out of 100 grams of my substance, I'm going to do the exact same thing. I'm going to use the molar masses of these substances, of these elements, and convert grams to moles. So I'm going to put this over 1. We saw the molar mass of potassium before is 39.10. So 39.10 grams of potassium on the bottom, 1 mole of potassium on top, and I'm going to calculate that, and I find to be 0.8995. So that's 0.8995 moles. And you'll notice that I keep about 3 or 4 digits here after the decimal. That's because I don't want to run into a rounding error, because remember, I'm going to be dividing these numbers, and if I round too much, I might have my my factors off here. I might have the subscripts off by a little bit, and I want to avoid that issue. So I usually keep about 3 or 4 decimal places. Next, I have sulfur, so I'm going to go ahead and move this up a little bit, 28,846. So 28,846 grams of sulfur. I'm going to put that over 1. Again, I'm going to multiply by the conversion factor of sulfur, which is 32.07. So I'm going to put 32.07 grams of sulfur on the bottom, and I'm going to put 1 mole of sulfur on top. So the grams cancel out here. I forgot to cancel out the grams. So I have moles of sulfur. So when I calculate the moles of sulfur, I get 0.8995. So I get 0.8995 moles. Here I got moles of potassium, moles of sulfur. Okay, so I got equal moles here. That's interesting. And then next, finally, I got oxygen. I'm going to move this up a little bit. 35,982, 35,982, 35,982 grams of oxygen over 1. And of course, I'm going to multiply by the conversion factor. So 15.9994 grams of oxygen on the bottom, 1 mole of oxygen on top. So grams of oxygen cancel out. So again, I'm going to get moles of oxygen. So when I calculate that, I get 2.2490. 2.2490 moles of oxygen. Okay, so now that I have my moles, I'm going to put that as my pseudo formula. These are going to be my subscripts for my pseudo formula. So I'm going to put it over here. I think I have enough room. So here I got potassium. I'm going to put the 0.8995, 0.8995. And then I've got sulfur. That's also going to be 0.8995. And then finally I got the oxygen, and it's going to be 2.2490, 2.2490. Okay, so there's my pseudo formula. Now I'm going to divide everything by the smallest number because I need a ratio of 1 to something. And that 1 to something, the something has to be greater than 1, right? So, or equal to 1. So I'm going to divide by the smallest number to do that. So since both of these are equal, they're equally small. So I'm going to divide by 0.8995. Divide that by 0.8995. Divide this by 0.8995. And divide this by 0.8995. And let's see what numbers I get. When I divide that, I get for oxygen, I get, well, for these, of course, it's just going to be 1. So I get K1, and this is 1, so I get sulfur 1. And then here, I actually get, oops. Sorry about that. So for the oxygen, I get 2.500, right? So basically I get 2.5. Well, here's the example of what I was saying before. I may not get a whole number, and here I can't round that. I can't round that to 3. That'll be a mistake. So here it's obviously a fraction of a half. So in order to get rid of the half, I need to multiply by 2. But if I multiply by 2, I need to multiply everything by 2 because right now, this is my ratio. This is the mole ratio that I got from the numbers, 1 to 1 to 2.5. I can't just multiply this by 2 and leave it that way because then the ratio won't be the same. I got to keep the ratio the same. So to keep the ratio the same, but get rid of the half, I need to multiply everything by 2. So when I multiply everything by 2, it's going to be K2S2O5. And so that, ladies and gentlemen, is the empirical formula. Now, you might be asked the question like, okay, so what's the name of this substance? So we obviously have a metal and non-metal. So this is an ionic substance. And also pay attention to the fact that, well, if you've got the metal, that's your positive ion. But then everything else has to be the negative ion. And notice, look, you have S, sulfur, and you have oxygen. So you've got a polyatomic ion here. So what polyatomic ion has sulfur and oxygen? Well, there's a couple of possibilities. It could be sulfite, SO3, 2 minus, or it could be sulfate, SO4, 2 minus, right? So here we've got S2O5, and so for every 2, we have 5 oxygens. So that is going to be, well, what would it be? It would be probably, doesn't really match either one. So in this case, we have a, let's double check here. Yeah, so for example, so this would be sulfite. If this was S or S2 or like SO3 instead of the 2, if it was SO3, this would be sulfite. If it was SO4, you would be sulfate, but doesn't match either of those. So in actuality, this ion here is your pyrosulfite or your pyrosulfite is one name, or you have what's the other name? Metabisulfite. So that would be the name of this substance here. But usually you're not asked to name these things. So that's your empirical formula. And so that's how you get your empirical formula from the percentages. So I hope this is helpful. If it is, then please like the video, share the video, hit that like button over there. Also, make sure you subscribe to my channel. Make sure you hit that notification bell. And when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question you want me to answer, a problem you want me to solve, or if you have a concept or a topic you want me to cover in a video, I would love to do that for you. Thanks for joining me and have a great day.